Hello, welcome to this lecture on modeling, analysis and estimation of three-phase unbalanced power network. So, we have been talking about the basic WLS technique. So, now let us start looking into the aspect that how to implement or rather use this technique for the state estimation of the three-phase unbalanced power network. So, to do that, so let us consider a very simple three-phase unbalanced network. So, I have just say this is, we will first do everything in terms of a very simple example and then we will try to generalize it. So, I have got this is bus 1, bus 2 and bus 3. So, this is bus 1, this is bus 2, this is bus 3 and I have got lines, and this is phase A, phase B, phase C. Now, please note that all these lines are actually being represented by the equivalent pi model, and what is that pi model we have already seen in our earlier lecture. So, we are not going to discuss it. Now, so then therefore, what are the quantities to be known? If I wish to know everything for this system, so then what are the quantities I have to know? I have to know the quantities VIP and theta IP. So, what is VIP? VIP is for I is equal to 1, 2, 3 and P is equal to A, B, C. So, what is VIP? VIP is the, we already know it, but anyway, voltage magnitude of at pth phase of ith bus. And what is theta IP? Theta IP is voltage angle at pth phase of ith bus, right. So, it appears that, but however, when I am trying to estimate the angles, I have to take one reference value. Usually we take, let us say that we are taking theta 1 A to be the reference value, reference angle we say. So, then therefore, theta 1 A would be is equal to 0. So, but then of course, for the other voltage magnitudes we are essentially measuring these voltage magnitudes with respect to ground. So, then therefore, in the case of voltage magnitudes our ground is the reference. So, then therefore, I do not have to take any reference among these voltage magnitudes of the system. So, then therefore, my unknown quantities, so the variables to be estimated are theta 1 B, theta 1 C, theta 2 A, theta 2 B, theta 2 C, theta 3 A, theta 3 B, theta 3 C. So, these are the angles, and also I have V 1 A, V 1 B, V 1 C, V 2 A, V 2 B, V 2 C, V 3 A, V 3 B, 3 C. So, I say that this is my theta vector this is my v vector. So, my theta vector is theta 1 b, theta 1 c up to. So, I can say that my theta vector is, so my theta vector is essentially theta 1 b, theta 1 c and dot 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 theta 3 b, theta 3 c. Say this is transpose. So, how many quantities are there? There are 8, 1, 2, 3, 4, 8. So, it is 8 cross 1 and my v vector is v1a, v1b, so dot 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 v3b, 3c. This is 9 cross 1, right. 9 cross 1 is 3 into 3, that means 3n. So, here n is equal to 3 because I have got total 3 buses. So, capital N is 3 and here it is 9 minus 1, that is 3n minus 1, correct. So, then therefore, in this case my total number of, so now, so then therefore, my, so now my state vector, I say my state vector would be x would be theta transpose t v transpose t and t. Why I am writing everything too many t's? Because you see theta vector we have defined as transpose. So, then therefore, it is theta is then basically 3n minus 1 column vector. So, it is basically column vector theta 1 b, theta 1 c and up to last row is theta 3 b, theta 3 c. So, when I am making it theta transpose, so it becomes a row vector. So, it is a theta 1 b, theta 1 c, theta 3 b, theta 3 c. Sorry, it is T T. Similarly, V is also a column vector. So, when I am doing V T, it is a row vector. So, then therefore, theta t is a row vector, V T is also a row vector and I am taking the transpose of this composite row vector. So, X becomes a column vector. And what is the size? The size is 17 cross 1. What is 17 cross 1? 6 into 3 minus 1, that means 6n minus 1. So, specifically x is, here is theta 1 b, theta 1 c dot 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 theta 3 b, theta 3 c and then v 1 a, v 1 b and then dot 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 v3b, v3c transpose. Right. So, this is the case for an simple simple 3 bus system. So, for a general n bus system, so this is my state vector and this is my state vector and so this is 7 cross 1. So, for a general, so then therefore, for a general n bus system, so then here in this case my number of state n is 17. So, it is 6n minus 1. What is n? N is the number of states. To be estimated. So, for a general n bus 3 phase system, for a general n bus 3 phase system, my theta vector would be essentially assuming that my theta 1 A is taken to be the reference. So, it is theta 1 B, theta 1 C dot 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 theta n B, theta n C transpose. So, how many of them would be? 3n minus 1 cross 1, right. So, there are altogether 3n, should be 3n if I have also taken theta 1, but 1 is less. So, it is 3n minus 1 cross 1 because this is a column vector. And what is the v vector? V vector would be v1a, v1b, then dot 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 vnb, vnc transpose. So, it would be 3n cross 1 vector. So, x vector would be theta t v t, all are transpose. So, it would be 6n minus 1 cross 1 vector. So, then therefore, so my n, so n here is always 6n minus 1. So, my number of states is 6n minus 1, and these are the states to be estimated. So, to estimate this n number of states, so then therefore, you can see that suppose capital N is just 100. So, then my number of states becomes 599. So, it is huge. On the other hand, for a simple balanced system, if capital N is 100, so it is just 2n minus 1, it becomes 199. So, the number of states to be estimated in the case of 3-phase state estimation is quite large anyway. So, my number of measurements m should be greater than n, that is should be greater than 6n minus 1. Now, please note, it is not always possible to put so many measurements in the system. So, essentially sometimes you also put something called pseudo measurements and etcetera etcetera, but then we are not going to go into those details. We are assuming that we are getting these measurements, whether they are real measurement or whether they are pseudo measurements, from somewhere, right. So, my number of measurements m should be greater than n, and that is equal to 6n minus 1. Now, what could be these measurements? So, these measurements could be, for example, PIP, these measurements could be QIP, these also could be PIJP, this also could be QIJP, right. This also could be magnitude of IIJP, right. Sometimes this also could be P say generator, right. P generator means this is the sum total of P generator I. So, it is nothing but PIP plus PIA plus PIB plus PIC. So, P generator I means that is the generated power by the generator located at ith bus. because it is the total 3 phase power. So, then therefore, this 3 phase power would be nothing but the sum total of the real power generated in phase A plus phase B plus phase C. So, these are the 6 types of, and also the measurements could be VIP. VIP and theta IP we have already defined. What is PIP? PIP is nothing but the injected real power at pth phase corresponding to ith bus. This is nothing but injected reactive power QIP at pth phase at corresponding to ith bus. What is PIJP? PIJP is the real power flow over the line Ij in phase A. Now, out of this we already know what are the expressions of PIP and QIP, that we have already derived. So, we will not going to derive it. So, we will just going to write it. So, it is just L is equal to A, B, C, J is equal to 1 to N, then it is VIP, VJL, YIJPL cosine theta IP, theta ij, yes. So, this is the expression of PIP. This we have already derived. So, we are not going to derive it again. So, you see, so this PIP expression is also the function of all voltage magnitudes as well as the angles except theta 1a, because that is theta 1 is taken to be 0. But so, then therefore, this PIP, it is basically a function of all voltage magnitudes as well as the all voltage angles except the reference angle. So, then therefore, I can simply say that this is a function PIP which is a function of x, where x is this, that I can say. Similarly, PIP. Similarly, QIP, we have seen that the L is equal to A, B, C, J is equal to 1 to N, VIP, VJL, YIJPL, so this is the expression of QIP, which also we have seen, and this is, so then therefore, I would say that this is also this is also function of x bar, correct. So, now let us look at, but we have not derived the expressions of PIJP, QIJP, IIIJP. So, let us look at that. So, now let us look. So, I have got bus I, bus J, and this is being, so it is being represented by a 3 cross 3 matrix. Let us say we call it Y series matrix, and this is also being represented by an Y shunt matrix. Right. So, this is the standard and so it is phase A, phase B, phase C, and right. So, this is the model of the line. So, it has got Y series as well as Y shunt matrices. Y series is basically a 3 cross 3 matrix. So, Y series matrices, for example, it would be something like Y I J A, Y I J A B, Y I J A C, and Y I J B A, Y I J B B, Y I J B C. Please note all these are complex quantities, and Y I J C A, Y I J C B, Y I J C C. So, this is the series matrix, and Y shunt matrix is also something like this. This is a complex matrix, So, this is also Y say shunt I J A, Y shunt I J A B, Y shunt I J A C, then Y shunt I J B A, Y shunt I J B B, B C, C A, C B, C C. So, this is the Y shunt matrix and this is the Y series matrix, right. So, now if I define, so then therefore, so this is I J A, this is I J B, and this is I J C, right. And okay, let me so this is J bus, this is phase ABC. My drawing is little bad, so please bear with me. And this current would be I J I A, that is from bus J to I J is, so let us define it, I J to I B, I J to I C. So, this is the current. So, we define, let us define this, that I J to I J P is the complex current in phase P. P is of course ABC over the line from bus I to bus J, and it is measured at bus I. That is important. So, IIJP means this is the complex current moving from bus I to bus J in phase P, but it is also being measured at bus I. For example, here we say Iij is here. So then therefore this is the current from bus I to bus j measured at phase A, Iij A, Iij B, and it is being measured at bus I. So then therefore what would be the expression of Iijp? So Iijp would be, of course, Y shunt, this is the matrix, into Vi ABC plus Y series matrix into Vi ABC minus Vj ABC. What is Vi ABC? Vi ABC is it is a vector. It is basically VIA, VIB, VIC. Please note all these are complex vector. So these are all complex, 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 complex. So all are complex. So if I put them, so IIJP, sorry, IIJ, I should write it. This is a wrong ABC. And what is IIJ ABC? IIJ ABC is IIJ, IIJ B, IIJ C. Right. So these are the vectors defined. So then therefore, so I can write it down that IIJA so I can write it down Y shunt IJ A I am just putting the, you know, the matrices as we have said, VIA, VIB, VIC plus Y IJ AA, Y IJ AB, AC, BA, BB, BC, CA, CB, CC. This would be VIA minus VJA, VIB minus VJB, VIC minus VJC. So this is the expression of IIJA. So, from here I can find out the expressions of Iij. So, for example, Iij would be, so for example, Iija would be L is equal to A, B, C, Y shunt Ij, Al, VIL. For example, L will vary from ABC. So, A, Ij, Al, AC, and then plus Y, Ij, Al into VIL minus VJL, right. So, this is L is equal to ABC, right. So, then therefore, similarly I can write down the expressions of phase B and phase C. So, then in general Iij at any phase P can be written as L is equal to A, B, C, then Y shunt Ij, PL, VIL plus Yij, PL to VIL minus VJL, right. L, and this P is varying from P is equal to A, B, C. So, this is the expression of Iij we have found out, right. So, from this expression we will try to find out the magnitude of this current as well as the power flow over the lines at any phase P. So, those all these derivations we will do in the next lecture. Thank you.